In this video, I'm going to do OCR A-Level Maths, Paper 1 from June 2023, Question 4. My name is Sunil Tanna. I'm a tutor and author. I'm available for one-to-one tuition both online and in person. I live in Buckinghamshire, England. Please like and subscribe. Question 4. It is given that the ABCD is a quadrilateral. The position vector of A is I plus j. The position vector of B is 3i plus 5j. Find the length of AB. Well, I like to write these vectors as column vectors. So OA, position vector of A, is I plus j, so 1, 1. And OB is 3i plus 5j, so 3, 5. We can find, for part A, we can find AB by doing B's position vector minus A's. So it will be 3, 5 minus 1, 1, which will give us 2, 4. And now we can use Pythagoras' theorem to calculate the length of AB. So AB will be equal to the square root of 2 squared plus 4 squared, which is, of course, root 20. Root 20 is the same as root 4 times root 5, so 2 root 5. So the answer is the length of AB is 2 root 5. Okay, part B. The position vector of C is Pi plus Pj, so OC is PP, and it says, given that the length of AB is equal to the length of BC, determine the position vector of C. So first of all, we can work out what BC is. BC will be P minus 3 and P minus 5. So the length of BC will be the square root of P minus 3 squared plus P minus 5 squared. But we already know that's equal to the length of AB, which is root 20 or 2 root 5, but I'll write it as root 20 here. So what we can do is we can square both of these. So we'll have P minus 3 squared plus P minus 5 squared is equal to 20. Now, if we expand out the brackets, we can get a quadratic equation in P and solve that. So the first one, P minus 3 squared, expand that out, becomes P squared minus 6P plus 9. P minus 5 squared will be plus P squared minus 10P plus 25, and that's equal to 20. Now, simplifying, we've got 2P squared minus 16P plus 9 and plus 25 is plus 34 equals to 20. Subtract 20 from both sides. So 2P squared minus 16P plus 14 is equal to 0. And they can notice everything divides by 2, which makes it a little bit easier to solve. P squared minus 8P plus 7 is equal to 0. Factorize that, it will be P minus 7, P minus 1 is equal to 0. So this tells us P is equal to 1 or P is equal to 7. And it tells us in the question, but P is greater than 1, which tells us P is equal to 7. So this is in the question, that P is greater than 1. So therefore OC is 7, 7, or 7i plus 7j if expressed in unit vectors. Okay, that completes part B. We now need to move to part C of the question, which I'm going to do on a new page. So for part C, and remember we now have this information. We have OA was 1, 1, OB was 3, 5, OC was 7, 7, and we also knew that the length of AB is equal to the length of BC. So, okay. Now, part C, we get this question here. M is the midpoint of AC, and given that MD equals 2BM, determine the position vector of D. So I'm going to draw a little sketch to kind of figure out what's going on. So first of all, A would be at 1, 1. So that would be A. B is at 3, 5, which I guess would probably be about there. C is at 7, 7, which I guess is going to kind of be like that, yeah. So like that, and these are equal length, AB and BC, right? Okay, M is the midpoint of AC. So if we go to here, M is halfway along that line here. So M is here, and these two halves are equal. Maybe I'll do that to show they're equal, right? And now D is remember the fourth point of the quadrilateral. MD is equal to 2BM. So we go to there. If we went twice as far, we would get to D, which I guess is going to be roughly around here somewhere. I don't know exactly where. Somewhere around here would be D. And the quadrilateral here, ABCD, would sort of look like that. Okay? What we need to do is M is the midpoint of AC. So the first thing we need to do is find what M is, yeah? So we can find AC by doing 7, 7 minus 1, 1, which gives us 6, 6, right? Is AC. So that tells us AM, since it's the midpoint of AC, it would be half of AC, which will be 3, 3. And now we can get the coordinates for point M, this midpoint here, because we know we can go to OA plus AM. So OM is equal to OA, go to A, and then follow AM. So it will be OA was 1, 1, and then we add 3, 3, which gives us 4, 4. So M here is 4, 4. It looks like it's more or less right on my diagram where M is, yeah? Right. Now we can work out what BM is. BM is going from B to M. So it will be 4, 4 minus 3 and minus 5. So it will be 1 minus 1. Right? And now it tells us in the question that MD is equal to 2BM. So MD is equal to 2BM. So it's 2 times 1 minus 1, so it will be 2 minus 2. And now, since we know the position of M, yeah, we can find what D is, yeah? So OD will be OM, go to M, and then follow MD. So OD will be OM, which was 4, 4, plus MD, which is 2 minus 2. So it will be 6, 2. So I've not quite drawn it right. I'm looking about 6 would be where D is here, and 2 up. So it's slightly off on my diagram. It's only a rough diagram, but it gives me a rough idea. So 6, 2 is OD. So D is 6I plus 2J. Okay. Next part here. State the name of the quadrilateral giving a reason for your answer. Well, if we look at it, it kind of looks like a kite already. We already know these two sides are equal. It would be a kite if we could either check by looking and seeing whether these two vectors cross at right angles. If you're familiar with the scalar or dot product, that would be one way to do it. But an easier way would be to check that these two sides, CD and AD, are of equal length. Yep. So let's do that here. So CD will be the position vector of D, which we've got as 6, 2, minus the position vector of C, which is 7, 7. So it'll be 6, 2, minus 7, 7, which will give us minus 1, 5. Yep, and then we can use the minus 1 minus 5, sorry, and then we can work out the length of that using Pythagoras' theorem. So the length of CD is equal to minus 1 squared plus minus 5 squared, which is root 26. Right. We can also work out what AD is. AD will be 6, 2 minus 1, which will give us 5 and 1. And then we can work out the length of AD, which will be 5 squared plus 1 squared inside a square root, which is also root 26. So therefore, the length of AD is equal to the length of CD. And we already know that the length of AB is equal to the length of BC. So since we've got this side here is equal to that side, these sides are equal, adjacent pairs of sides are equal, so we have therefore ABCD is a kite. And that completes question 4.